Hello everyone, so I hope you all are fine. I'm Natasha and welcome back. So today we're going to continue chapter 1 and that is sets. So in the last video we discussed about we did some practice questions. We did some practice questions on this chapter and and in this video, we're going to continue our the topic that we were discussing. That was some practical problems on intersection and union of two sets. So let's get started. So first of all, I'm going to write the heading and then we're going to continue. So what was it? It was practical problems on union and intersection. Let me write it here. Intersection of two sets. Never mind, whatever. So I was saying that we're going to discuss about the practical problems on union and intersection of two sets. So we discussed, we did some, we did some two things, in the previous video, rather than, I'm not actually talking about the practice questions. I'm talking about those methods, those were basically the methods to solve the questions, which are related to the union and intersection of two sets, means the practical problems. So we discussed earlier that first was to find no need to write it on the board. So to find the intersection and or union of two sets, how can we find out? So that's what we discussed about. So that's what we're discussing about. So now today we're gonna discuss about the third one, because we have already discussed the first and second case. Now it's the third case. If we have more than two sets, and if they're all finite sets. So let's have a look. So the third one, which I'm going to write, is going to be if set A, B, and C are finite sets, then let's say we have to find the number of elements in A union B union C, so is equal to, it's like a formula that we're going to write. So that I'm going to write. So it's like a formula which we're going to use in the questions in which we have more than two sets, and of course if there are finite sets. Of course there will be finite sets, and if not, then we'll discuss about it in a different way. So for now, let's just discuss on, let's just focus on this topic. So the number of elements in A union B union C. So we have more than two sets. So we have total 3 sets. And we have to find their union. So how many number of elements? So how many number of elements will be there, in the sets? So for that, we have a formula, and it is really easy. So let me write it. And then we'll, discuss the, then we'll prove it also. So the number of elements in A union B union C is equal to the number of elements in set A plus the number of elements in set B minus the number of elements in A intersection B union C. So there, first of all, the union of set union of these two sets, and then their intersection with set A. So do you remember this thing? This one is actually by the second case we did. If you have remembered. If you don't know, or have you forgot it? Whatever it is. So let's just not talk about it. So yeah, actually it was like this way. So like we have to find the number of elements in A union B is equal to the number of elements in set A plus the number of elements in set B minus number of elements in A intersection B. It was right, it's opposite, isn't it? This was the second. Okay, yeah, I hope you all, I hope you haven't forgot yet. So yeah, so what we're going to do in this one is actually I'm just like proving it first, and then I'm gonna tell you the final one, like what exactly its solution is going to be. So what exactly, like what result we're gonna get. Okay, so let's continue. So now we're gonna discuss actually we're gonna move on. So this one was the second one, and now let's after sorting it out more, so what are we gonna get? So number of elements in set A plus the number of elements in set B minus number of elements in B union C minus number of elements in A intersection and then the B union C. Okay, have a look. Is it clear? Yeah, so like we have took now, we have took them separately, like B union C. Okay, so let's move on to our next step. So as we can see that what we're getting is what result we're getting is actually that that number of elements in A intersection B union C is equal to the number of elements in set A plus the number of elements in set B minus number of elements in B union C and minus number of elements in A union B union. Oh no, actually it's not the step. Yeah, it's actually a little bit separated. So we have actually separated. So let's see how do we got it. Okay, so first method that we're gonna get is going to be actually the intersection of both of the sets. So A intersection B union A intersection C. That's what we can see. So let me tell you how. Okay, so actually it's not the same like before, like the previous one. So let me show you what's like different in them. Okay, this one's also like after sorting all of them out. So after sorting them, what are we gonna get? Okay, so actually we're gonna get the number. A intersection B union A intersection C. Can you guess it? Like how is it possible? Like how did I write it, or what I think, what I thought actually it was. It's if you have remembered the properties on intersection of sets or union of sets. In both of the sets we have some common properties, and the first one was actually distributive law. I think in both the sets, actually it was actually in both of the sets. So this is what I'm talking about. So this is exactly the distributive law that we followed. So that's it. And now we get, what are we gonna get? So what do you have to exactly find out is the number of elements in A union B union C, as we can see. Okay, so but before that we're gonna find out the number of elements in A intersection B union C. Like we're gonna follow the step. So let's continue. Yeah. Okay. We get the whatever. So it's actually we get. So now we're gonna get we get the number of elements in A intersection B union C is equal to the number of elements in A intersection B minus number of elements in A intersection C minus number of elements in A intersection B union A intersection C. Okay, just have a look. Is it clear? Like they're gonna be negative. So actually, yeah. Not this one. Actually, this is gonna be actually negative. This is gonna be positive. So like what we had in this case was actually whole positive. But in this case, like it's that's what we're following. So in the first case, we had this thing. In the second, it's like the same by the second one. Okay, that's what we have. So positive, positive, and then negative in the last one we have. Okay, yeah. So then next step, what are we gonna get? So this is number of elements in A intersection B plus the number of elements in A intersection C negative number, minus number of elements in A intersection B and then their union with A intersection C. Okay, so to find the number of elements in A union B union C, what are we gonna get? So after sorting them out, like after solving in all these things, in the final we're gonna get something really similar that we have seen. Actually, after like sorting this thing out, then what are we gonna get? So we're actually gonna get the number of elements in A intersection B plus number of elements in A intersection C minus number of elements in A intersection B intersection C. Isn't it common? Of course it is common. Like have a look, like the number of elements in A intersection B intersection C, and that's what we have in opposite side. So to find the union of set, one thing is gonna be actually on its opposite side. So like it's in left hand side, so on the right hand side we're gonna have its intersection of sets to solve it. So we have their number of elements of both the sets and then their intersection, or like if we have to find the union of their sets, then intersection is going to be there. If we have to find the intersection, union is going to be there. So that's what we have. So finally we got A intersection B intersection C, and that's what we have. So therefore the number of elements in A union B union C is equal to the number of elements in A intersection B plus number of elements in A intersection C minus number of elements in A intersection B intersection C. Okay, and this proves our third one. And yeah, actually, so in the last data that I was about to tell you the final results. So actually, after solving it, so like this is like a formula we have. So after solving it, if three sets are, if more than three, let's say so 3, okay. So if we have 3 sets and those sets are finite sets, then what is going to be the formula? Actually, the formula is going to be the number of elements in, let's say we have to find union, so A union B union C is equal to the number of elements in A intersection B plus the number of elements in A intersection C minus number of elements in A intersection B intersection C. So here we can find the union set of 3 of more than 2 sets. Okay, so that is the formula basically. Is it clear? Okay, so I hope it is clear to you. And and there's like a little bit also, we haven't done all of them, so it's like a little bit incomplete because we didn't wrote about the B intersection C. We forgot about B intersection C because we also had set B, so that I forgot to write. So it's actually, it's more than 2 sets. So we have set A, B, and C. So in the final one, actually, it's going to be the number of elements in A intersection B plus the number of elements in A intersection C. They're all going to be negative. And then the final one that we're going to get is going to be actually a little bit difficult. Oh, sorry, not the difficult. It's actually going to be the different. Okay, so let me tell you how is it. So it's a little bit, different from the one that I wrote. So it's actually like this way, okay? So it's actually, this formula is basically for the sets, for the 2 sets. But, if we're having 3 sets, so like we have to solve all of them. So, but yeah, I forgot to write about set B, there, relations with the sets, so that's what we have. And yeah, there's important, like we have to write the number of those particular sets, like number of elements in set A, number of elements in set B, and number of elements in set C. So those are like included in all the whether it's more than 2 sets or less than 2 sets. Oh, of course it's gonna be like not the 1 set, but we can say it's like gonna be in the pattern, like a different pattern, isn't it? Okay, so the final one that I'm going to write, after sorting this out and remembering that set B is also there. So let me just rub this and write the final one, which will prove our third case, the third case that, the result that we're going to get. So this is how we're you're just proving it, like how did we get that formula. So the number of elements in A, union B, union, it's actually like I've already written it, so I'm going to just rub this directly. No need to write it again. Okay, so here I'm going to rub. Okay, it's almost done. Okay, so let's just not get confused. So, in the first it's a little bit confused, but after understanding it completely, like it's really easy. Okay, so therefore the number of elements in A, union B, union C is equal to the number of elements in set A plus the number of elements in set B plus the number of elements in set C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C and plus number of elements in A intersection B intersection C. So this actually proves so this proves us the third case. Third case. Okay, so the final result, after sorting them out in the, like complete relation, so that's what we're gonna get. So this is gonna be actually our final answer, and that's what we have. So like we have a formula for that. So, and the formula is actually this one. Okay, like a little bit big enough because there are more than 2 sets, that's why. Like we have total 3 sets. So first of all, they're single ones, and then they're, pairs, and then the final in all the 3. Like what do we do in power set? In power set, like we make relations. So first of all, like if we have like elements 1, 2, 3. So first of all, I'm going to write them in singleton sets, and then they're pair with each other, and then all the 3, isn't it? So the single, and then the pairs, and then all the 3, and of course the 5. Yeah, or whatever. Okay, we're just not discussing about it. So that's what we have in this case also. So just have a look. So all the things that we're separating in, like, this is finally what we're gonna get. number of elements in set A plus number of elements in set B plus the number of elements in set C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus number of elements in A intersection B intersection C. And what if we have to find the intersection? Like, it's going to be really same. So it's going to be actually, here we're going to write the intersections one, and here we'll write A union B, B union C, A union C, and A union B union C. Okay, because like we can't found like, it would be like impossible for us to find out, without their union. So yeah, maybe it's going to be like given to us, so that would be like in different case, but this is how the pattern will go on. Okay, so I hope you all have understood everything that we have discussed, and so that's all for today, and see you in the next video. So thanks for watching and have a great day.